Okay, so in this problem here, we're going to be doing 17 and 18. Similar to what we just talked about in the previous two. A is 1. Okay, so like I'm looking, A is 1, B is 1, so I can't complete the square. We tried trying to think about factoring, like numbers that multiply to 7 but add up to 1. They don't exist, so because of that, the only option I can do in number 7 is the quadratic formula. Negative b plus minus square root b squared minus 4 times a times c all over 2 times a. Okay, simplify. Negative 1 plus minus square root. 1 squared minus 4 times 1 times 7 gives us a negative 27 all over 2. Alright, so we have to simplify a radical. So negative 27, take out the negative. Simplify numbers that multiply to 27, 9 times 3. Break this down to 3 times 3 times 3. Here's my pair. So it's negative 1 plus minus 3, and then the imaginary number I, square root 3, all over 2. And the last step would be just to separate them. Negative 1 over 2 plus minus 3i radical 3 all over 2. There's no simplifying anywhere. I'm done. Okay? We're looking at number 18 now. I cannot take the square root because I have two variables. I can't complete the square because a is not 1. So I'm either going to be factoring or I'm going to be quadratic function. When we did in 15 and 16, a was 1, so I want to try factoring. Here, a is definitely not 1, so maybe I'm just going to go right to quadratic function. And to do that, I have to set this equal to 0. So I get 3n squared minus 10n plus 11 equals 0. So now for the quadratic formula, to do the quadratic formula, it's just going to be negative 10 plus minus square root, negative 10 squared minus 4 times 3 times 11 all over 2 times 3. Simplify. 10 plus minus square root, okay? Negative 10 squared minus 4 times 3 times 11 gives us a value of negative 32 all over 6. Just like we did over here, we got to simplify negative 32 down to its parts. I like to try to think in terms of perfect squares, so like 16 and 2. And the reason why I like 16 because it goes to 4 times 4 times 2. Here's your 4 that can go out, so I got 10 plus minus. The 4 comes out, my imaginary I comes out, radical 2, and over 6. So we can simplify here. I'm noticing that I'm going to have 10 over 6 plus minus for I square root 2 over 6. I can simplify 10 over 6 to 5 over 3. Plus minus 2 over 6 to 2i over 3. Notice that the I and the 2 inside the radical do not change.